Okay, here's part two. I just realized that the website I'm using has 15-minute um, limits. It's a long time to talk, but I have more talking to do. So I think we left off here. We're talking about cabbage worms living in their food. Um, Pests usually don't destroy their homes because their food is their home unless given no option, which means most pests, even modestly to severe damage, they don't completely eat all their food. They don't completely destroy the crop. They usually just create kind of economic damage or some visual damage, but typically they don't kill the plant that they're eating, which is a good thing and something we can work with. The other thing we found through research and understanding is that insect pests often single out unhealthy stress or dying plants or dying tissue. And in this way, they aid in the decomposition process. So um, we see this over and over again that something that is considered a predator of a species or a disease often have the overall impact on the system to make the species stronger or more healthy. Think about it like if disease plants were allowed to just stay upright or not be consumed, then they might pass on or breed the diseases that are killing them. Whereas if a pest comes in and eats it all down because it's half killed by fungus, that might help to reduce the overall fungal loads in the system. You see this in wolves and moose or whatever, like the crippled older moose are often the ones that the wolves can catch and eat, whereas they can't take down a healthy moose. This comes up again and again in nature. It's quite the same in our gardens. Um, so the overall vibe is that by understanding pests, we get an advantage, not just over them, but we get an advantage in understanding how to work with them and against them at the same time. That's the theme, right? The paradox of working with something and against something is what we call coopetition. And Tip is really good at this because she'll see weeds as herbs or weeds as something you could use to enhance a dish or a meal, or even the beauty of a polyculture system if it's in the right place, right? So she's a big proponent of weeding and she does it really well and she has people weed quite a bit, but she also leaves some key weeds as um, as indicator species or as something to learn from or as a healthful herb to get into our diet. The craziest thing I've seen sometimes is like people poisoning their lawns so that only grass can grow, and a lot of the times they're poisoning plants that can directly benefit their lives. I mean, dandelions, for example, feed bees, but beyond that, they have lots of vitamin A and lots of calcium, and these are still nutrient deficiencies we see even in first world countries. So it's ironic to me to see so much money invested in poisoning some of the very plants that could help us alleviate some of our health problems, and they're right there in front of us. And how clever it was for nature, or for God, or whoever, or whomever, or whatever you put in place there, presenting it to us so clearly. Right? Nothing's more obvious than a dandelion in spring, and we could either work with it by digging it up and eating it, or digging it up and putting it somewhere else, or leaving it there, or we could, call up True Green and have them come and spray something that we definitely know is not good for our health to eliminate the diversity in our lawn. So when we look out, we just see green and nothing else. Um, so these are some elements. You could sort of read them on their own. In the end, we need to understand that our gardens and farms are going to be strange, manipulated, messed up ecosystems. And we could push them in the direction of being a harmonious ecosystem. But in the end, we're trying to do something pretty greedy in a way. We're trying to create a landscape that serves only our goals. Um, Sometimes our goals are shared with others. So like flower gardens, serve the goals of being something attractive to look at, while also serving the goals of bees in their life, getting nectar or other insects that can kind of live there incidentally. But in the end, when we're farming and gardening, we're trying to feed ourselves, and we have to take some measures against pests to make sure that happens. So when we do that, the first line would be to use avoidance tactics like row covers. For example, this is a way to avoid pest damage by just simply excluding them and not using anything toxic or not using a pesticide. So row covers are this thin fabric that lets water and light in, but doesn't let pests through. You might have seen some of that on our farm. It's a good version or a good example of an avoidance tactic. We could shift our planting dates. A famous example of this is the Hessian fly. It's a fly from Europe that came over with wheat culture, and that here in the United States lays its eggs, and the little root maggots go down and eat the roots of the wheat and damage the crop. Whereas we learned that if we plant the wheat later, after a certain date, that damage doesn't occur because of the pest life cycle. So by avoiding the pest in time, in the space of the season, we could also get some of the same benefits. In trap crops, this is a perfect example is the bok choy and the lettuce rafts. The aphids come in and prefer the bok choy, but they show when the aphids show up, they show up on the bok choy first, and they also give the aphids something to chew on before the lettuce crop matures. Then we can go and just throw away the bok choy or compost it and get our lettuces free of aphids. So a trap crop is a kind of avoidance tactic. The last ditch effort would be to try to kill the pests directly. In organics, we can use plant poisons, so like extracts of mums, extracts of castor bean. These are poisons that kill bugs. Bacteria, we could culture certain bacteria that will kill the insects, and that's an organic tactic. Of course, fungus, some kinds of fungi will eat insects. We could use a flaming wand to steam weeds. So these are ways we could do it organically. On a conventional farms or conventional gardens, we could use a diversity of plant and pest poisons that we call pesticides. But this can have some serious effects on your health or the health of your ecosystem, and should only be used as a last resort. Here, check this out. This is a cool TED Talk by a cool gardener in LA talking about some of the things we discussed. It's a little break from hearing me and seeing me. Why don't you check it out? We're doing some of the stuff that's happening in all major cities, including Kalamazoo, and of course big time in Detroit, where we're starting to use some of our urban landscapes to do more feeding of ourselves. 50 years ago, cities were just kind of places where food production didn't happen. It's something we did on the outside of towns in rural areas, and we're finding that gardens can have healthy interactions with cities, and as we learn, urban farming and urban gardening is taking off. So here's the quiz. I think it all should make sense to you. Take that, get it back to me via email. You can take a break right now. I'm going to keep going. Okay, so the last element of this total discussion we have to go over is how plants get their nutrients, or how plants get their fertility. And there's a major break in how we understand this and how this works, and I want to present it as clearly as I can. The break is between an organic life-based system for delivering nutrients and the more recent, like in the past 100 years, a soluble plant nutrition. These are both kind of like worldviews or patterns or programs of understanding. They have some overlap between the two of them, but for our purposes, we're going to call the life-based system for providing nutrients, we'll call that organic, and the chemical soluble base we'll call soluble. Soluble just means dissolvable in water, right? So salt is soluble in water. So most of or all of the kind of fertilizers you use that you can get in a bag will dissolve in water. When you put them in water, they'll the two elements in the compound will break apart and be fully dissolved in the water. Whereas an organic nutrient system, there's lots of different ways nitrogen can be provided, for example, or any of the other major nutrients are provided in an organic system through some kind of life form initially. So in this way, organic means anything that was once alive or is now alive. So we're all organic matter. Everything we eat is pretty much organic matter, except for salt. Salt's the one non-life form that we eat and get food from, or get as part of our essential part of our diet. And up until 100 years ago, when humans discovered soluble nutrients, plants on the planet have gotten all their nutrients from decomposing life forms and weathered rocks. So decomposing life is just like the compost pile. Everything goes in green, turns brown, looks more or less the same. You know, a decomposing deer and a decomposing tomato plant will all eventually become kind of a black, gooey compostiness. Weathered rocks are also the other fraction of soil that provides nutrients, are like stones that get ground up by the wind or smashed up by years and years of rain, or get beaten up by roots and different life forms that dissolve away the rock. So soil can basically be seen as part decomposing life, that's the humus, the black stuff in the soil, and part weathered rocks, that's the sand, silt, and clay that make up soil. So that's what we mean when we say organic. When we say soluble, we mean chemicals that contain the nutrients plant use in the form that dissolves in water. So we do understand that plants take up nutrients in soluble form. So in the organic system, an organic farm or garden or in a forest, eventually this process of weathering and decomposing will produce chemicals in a soluble form. That's the way plants take them in. What we learned in the early 20th century is that you could just create those chemicals in soluble form and deliver them directly to the plants and sort of bypass this decomposition and weathering process. And in doing so, you could dramatically increase crop yields because you're not waiting around for decomposition to happen. You're not waiting around for weathering to happen. You can make all those processes happen quickly in a factory or a lab to produce the chemicals that will become the nutrients for the plants. So this is what I mean here. The plants can also get their nutrients from chemicals that people make. This is just a simple graph showing the rise in the fossil fuel supply and how it's linked to consumption, but also these blue bars are gross domestic products, so it's like an overall measure of economic activity. And it should come as no surprise that when our society uses more energy, we have more economic activity. So a lot of what we could see is the progress of the last 100 years is simply a burp or a kick in a butt from this massive new energy source called fossil fuels. And of course, fossil fuels being made into fertilizers are a big part of agriculture. Let's see how much time we have. Not much. So here's some examples of organic fertility inputs and what they have. Here's some soluble examples of those similar ones. I'm going to run out of time here, but I want you to get on to make sure you check out this presentation. It kind of fills in some gaps of what I'm leaving. It's a little awkward and strange. Here's the quiz.